Hello everyone, I want to talk to you about integration by parts, and this process is different than U substitution. You'll notice from your notes I'm showing you your notes directly, so please print those out so that you can follow along. It says the antiderivative of U dV is equal to UV minus the antiderivative of V du. And we'll go over how this works. There are guidelines for choosing U and dV. Your du should be simpler than your du should be simpler than your u, and your dv should be easy to integrate. Okay, so I want to do the problem that I've given you, and that is the antiderivative of x times e dx dx. Okay, so if we look at this, you might think that it's u substitution, but we don't have anything that has its derivative also in the problem. So for example, if we chose u to be e dx, then the derivative of this would be e dx, and there'd have to be another e dx right there. If we chose u to be x, then the derivative of that would be 1, and we'd have an extra e dx sitting there. Okay, so there's no simple way or a u substitution that can be done in order to take this antiderivative. So we're going to do this using integration by parts. So what I do is I typically create a table that has u in it, du, and then it has v and dv. Right? So it has all of those pieces. Alright. So I'm going to show you two different approaches so that you can see which one is the correct one. Sorry about that. Okay, so the formula says that when you take the antiderivative of u dv, this equals uv minus the integral of v du. Alright, so one of these has to be u and the other one has to be a dv. I don't know which one is which at this particular point, so I'm just going to make an educated guess. So I'm going to let e dx equal my u, and I'll let the x part equal my dv. Like I said, one has to be u, because that's what the label says. The other one has to be dv. Okay, dx is going to go here. Alright, so this one says take the derivative of your u. Whatever your u is, take the derivative. So if u is e dx, its derivative has to be e dx. Okay, so you're taking the derivative to go this way, but if you're going the opposite way, you're taking the antiderivative. So for this, we want to find the antiderivative of x dx, which, if you remember, that's at 1 to the power, which is x squared, divide by the new power over 2. Right, so let me show you that. Alright, so then we want to be able to combine that using the formula, right? So we've chosen our u. Let me be clear about what I did. That's what I made u. And then the rest of this or the dv part. Right? So everything's accounted for. Alright, so according to the formula, it says take what your u was. So the integral of x e dx dx, this equals, your u was e dx. It says multiply by whatever your v is, which we got x squared over 2, minus the integral of your v, which is x squared over 2, times your du. Now I was not careful here. If this is u, then you have to acknowledge here that you did take the derivative with respect to x. So here, e dx dx. Alright, so notice this does seem to be a rather complex process, and indeed it is. However, we should know if we're going in the right direction by comparing what we started with this antiderivative. So if this antiderivative gets more complex, then we're going in the wrong direction. We made the wrong choice for u and dv. Okay, so see how this one has x to the first power? And then e dx. Look at this one. This one says x squared e dx dx. So this is the wrong way to do it. This is a no. Okay, so I should be getting to a simpler place for this antiderivative, and that's what told me that I need to stop and start something else. All right, so let me make a different choice for my u and my dv. Okay, so what if instead, okay, so I have this integral of x e dx dx. Okay, I have u equals du equals, and then over here I have v equals dv equals. All right, so in the last one, and let me show you which two we absolutely have to choose, right? The formula says the integral of u dv equals uv minus the integral of v du. All right, so we have to choose something for the u and we have to choose something for the dv. All right, so in the last one I let u equal e dx, but this time I'm going to let u equal x. Let's just do that. And my dv, I'll let that equal what's left. So e dx dx, like that. All right, so let's finish the rest of it. So if u is x and the derivative of that is 1 dx, and now I need to take the antiderivative to get back to v if I'm at the derivative of v. So this is the antiderivative of e dx dx, which if you remember is simply just e dx, right? Or 1 over 1 times e dx. That's the shortcut. Okay, so now let's try to plug this into our formula and see how this works out. So the antiderivative of x times e dx dx is equal to u, there's my u, times v, okay, there's my v, e dx, minus the integral of v, which is still e dx, times du. Now my du is 1 dx. Like that. Alright, so I can look at what I started off with and what I ended up with, and I can already see I'm in a better spot. Right? This is x to the first. Down here, I have x to the 0th, or 1. Right? So the power of x is decreasing, and I still just have the e dx. Alright, so what I typically say is don't do anything until you smash those two together, right? Try to simplify that before you do anything else. Smash them together. So this equals x e dx minus the integral of e dx dx. Alright? Wait, we know how to do this one. We got a shortcut for it. Right? So this is e to the 1x. So that part is 1 over 1 times e to the 1x. And then the first part, we don't have to do anything because it's not in an antiderivative. Plus c. Notice we are finally outside of that antiderivative, which is exactly where we want it to be. And you're done. That is the entire process for that problem. Okay, let me recap. They're going to give you a problem and they're going to say, find the antiderivative. You might not be able to do u substitution. Maybe you don't have the derivative of something already in the problem. If that's the case, you have to do integration by parts, which means you have to assign the pieces that are in your problems either to u or dv. Okay, so after you've done that, you're going to fill out this table, and then you're going to check to see whether this antiderivative that you get with this integration by parts process gets you closer to where you want to go than where you already were. So if this gets more complicated than what you started off with, you're going in the wrong direction, which is why it says no. Okay, down here, you notice this one says x e to the x, whereas down here it just says e to the x. So I know I'm going in the right direction, and that gets me out of my antiderivative fairly easily.